So good afternoon, everyone. And in today's class, this is lecture number 5. We'll try to wind up this topic. Not nothing much is left. The only thing that is left is motion of bodies which are connected. How we solve this question of connected bodies? Normally, this entire section has a procedure of solving question, but the sort of question that you are going to get, it may not require any procedure. The procedure is, you'll have to draw the free body diagrams and all, and this you don't have to do all of those things, because the question that you are going to face are going to be pretty straightforward. When I say pretty straightforward, that means they would be straight. You have the question and you'll have to solve it, because you will get very less time to solve it, right? Now, instead of going through the procedure for each and every question, let us solve the question as different examples, and I hope you can remember those examples and use them to solve any question that comes. For example, let us start with motion of a block on a horizontal surface. So you can write this heading: motion of a block on a horizontal surface. So we'll do it under motion of a block on a horizontal surface. That is the heading. Block would be kept on horizontal surface and we'll have to study its motion. Now we'll do it case wise. So let us see case number 1. Case number 1. Let me first show you the diagram, and then we can discuss them. All these are potential questions and we are doing them as examples, so that you can understand the question as well as you can solve it. Now, this is case number 1. What is in this case is, you have a block of mass m kept on ground, and you apply a force F on it. Remember, friction is not coming here, because friction we will do it as a separate topic. So what all things will come here? Remember, whenever you have to solve any question, the first step of solving question is to draw a free body diagram. Do you remember it? So what we have done is we have drawn a free body diagram. We have drawn all the forces. You can see all the forces here. What are the forces acting on this? This is the normal reaction N. They have called it R. This is the weight of the body mg, and this is the horizontal force F. You see all these three forces, yes or no? Now this block is going to move only in the horizontal direction. It cannot move in the vertical direction. Therefore, the vertical forces will balance each other out. It will be in equilibrium on the vertical side. So upward force will be equal to downward force. So you can write the first equation will be, your R will be equal to mg. Do we understand this, bacha? On the right you see a force F. On the left there is no force. So this force, net force, is F. This F will be equal to mass multiplied by the acceleration of this block. Or from here you can straight away find the acceleration of this block as F by m. Do you understand this? If you get a question like this, the question is pretty damn simple. Reaction or normal reaction N is equal to mg, and your force is equal to ma, or your acceleration will be force multiplied by force divided by the mass. Do we understand this? Simple now. Have you noted down that case, bacha? Okay. Then you can do the second case. Shall we move on? Okay. Now in the second case, what has been done that instead of applying the force horizontally, they've applied the force at an angle. Do you see this angle theta? They've applied the force at an angle theta. Now what happens in this case is whenever you solve any question, you have to draw one axis as x-axis and one axis as y-axis. In most of the cases, you take your horizontal axis as x-axis and you take your vertical axis as y-axis if it is kept on a horizontal ground. Now this force is not coming along horizontal and vertical, so you will have to resolve it. So you get one component f cos theta which goes along horizontal, and you get another component f sin theta which goes along vertical. We see this, yes or no? One component of force f cos theta goes along horizontal, one component of force f sin theta goes along vertical. Again, it does not move here. Can you tell me the equation on the vertical axis? How will the equation on vertical axis look like? Vertical axis mean y-axis. What will be the equation of vertical axis? Y-axis. Can you tell me what will be the equation of vertical axis? You can see these forces. Can you tell me what is the equation on vertical axis? It does not move along vertical axis. Can you tell me what is the equation? I am waiting, beta. No one knows the equation? Please try. It does not move along y-axis. What will be the equation on y-axis? Anyone? Remember, no answer is right or wrong. There must be some thinking that you have. What is the equation on y-axis?
F sin theta into R is equals to mg.
F, I hear you half. Maybe I'm hearing you correctly. F sin theta. You said F sin theta. It's upwards. R is also upwards. So F sin theta plus R will be equal to mg. That is the equation along y-axis. Can you now tell me what is the equation along x-axis? What is the equation along x-axis? It has to move along x-axis. Its acceleration is going to be a. Can you tell me what is the equation along x-axis, beta? The force along x-axis is F cos theta. There is no other force here. So that will be equal to m into a, or you can write acceleration as f cos theta divided by m. So these are the three equations. They might ask you the value of r or normal reaction n. They might ask you the value of acceleration. With this small diagram, you should be able to get the values for any question. I hope we are able to understand this. Once I show you the diagram, please try and do it by yourself. If you only note it down from the whiteboard beta, that is not going to help your cause unless and until you also try to understand this. So that is my effort, that you also try to understand what is happening, how are the equations written. That will help your understanding. Now, what I have done or what is there in the diagram is, instead of applying the force upwards like this, the force is applied in the downward direction. Previous case, it was a pull. You were pulling it upwards. Now it's a push. You are pushing it downwards. The angle is given as theta, as you can see here. The angle is given as theta. Again, you can resolve this force along two axes. Remember, your horizontal axis is your x-axis and your vertical axis is your y-axis. You have resolved this force along two directions, like one like this and one going downwards now like this. Your weight is also downwards. Your f sine theta is also downwards, but your acceleration has to be in this direction. Can anyone tell me what is the equation along y-axis? It is not going to move along y-axis. It is in equilibrium along y-axis. Can anyone tell me the equation? Can anyone tell me the equation along y-axis? Yes? F no one knows it. F sine theta, which is downwards, plus mg, which is also downwards, is equal to r. R is the only force in the upward direction. Mg and F sine theta both are in the downward direction. So F sine theta plus mg, downward force, must be equal to r, the upward force. Can you tell me the equation number 2 along x-axis?
F cos theta equals to MA.
F cos theta equals ma. Well done. That is the answer. So from here you can get the value of a, f cos theta divided by m. Well done. That is the correct answer. That is the correct answer. I hope everyone is noting it down. Anyone has noted this down? Yes or no?
Yes, sir.
Okay. That takes us to the next case, case number 4. And in this case number 4, the block is kept on an incline, smooth incline, which is inclined at an angle of theta. Now, how do we do this question? Again, we draw the free body diagram. This weight mg, the weight of this is mg, it goes downwards, and the normal reaction is r, which goes upwards. We remember this free body diagram, yes or no? But in this case, beta, up till now we were making horizontal and vertical as your x and y axis. Here this particle is going to move along the incline, so it's better if you make our x and y axis, as I told you, like this. Did I tell you that, yes or no? That this would be your x axis and this would be your y axis. Did I tell you, yes or no? Yes or no? Do we remember this? Okay. Now, this weight mg is not lying along the horizontal and vertical. So what will I do? Or what will we do? We will resolve this weight into two components. And I told you the component which comes along the incline is mg sine theta. Do we remember this? This is mg sine theta. And the component which comes here is mg cos theta. The component which comes perpendicular to this is mg cos theta. We must understand that this block is not moving along the y-axis. It does not move like this. You can see a force here. You can see a force along y-axis. This is the y-axis. Can anyone tell me what will be the equation along y-axis here?
R equals to mg cos theta.
Well done, bacha. That is the equation. R is equal to mg cos theta. That is the equation along y-axis. Now also just apply some common sense and tell me in which direction will it move? Will it move upwards? Can it go upwards or will it move downwards? Will it move upwards or will it move downwards? A block kept on an inclined plane like this. Where will it move? Will it move downwards or will it move upwards? Tell me. The only reason is the only place it can move is downwards. Yes or no? Let us call the acceleration as A. Can you now anyone tell me the equation along x-axis for this block? The equation on x-axis for this block. Remember, x-axis is like this and y-axis is like this. Can you now tell me the equation along x-axis for this block?
A equals to mg sin theta.
A is acceleration. Mg sin theta is force. Can you again think what you are saying? You can take inspiration from here, from this equation. Force is equal to m into A. You can take inspiration from here. And try again. What will be the equation along x-axis?
mg sin theta is equals to ma.
Yes, mg sin theta, which is the force, that will be equal to m into A. M and m will cancel, my dear friends. And remember, in this case, the acceleration is equal to g sin theta. Whenever you have a block kept on a smooth inclined plane, the downward acceleration is always equal to g sin theta. Very important result that you must remember. Do we understand this? Yes or no? This has gone above. We're saying bye bye, bye bye, bye bye. I'm going. Huh? Okay. I'll give you 2 minutes to note it down.
Completed, sir.
Shall we move ahead?
Yes, sir.
We move on to case number 5. And case number 5 is like this. I've drawn the free body diagram, everything here. Now, here, again the same thing. You can see some forces along y-axis and some forces along x-axis. You can straight away tell me the equation along y-axis. What is the equation along y-axis? What is the equation along y-axis?
R equals to mg cos theta.
So that equation is always valid. R, or normal reaction, R is equal to mg cos theta. Now here are two cases possible. Two cases possible. As you can see, there is this small force, there is a force F which is acting in the upward direction. Do you see this? And then there is this force mg sine theta which comes because of weight. Now, there are two cases possible. Sorry, three cases possible. Three cases possible. What are the three cases that are possible here? What are the three cases that are possible here? There are three cases possible. Can you tell me, anyone, what are the three cases? Case number E. If F is equal to mg sine theta, they both can be equal. They both can be equal. Then what will happen?
mg equals to ma.
If F, upward force, and mg sine theta, downward force, both are equal, then what will happen? Then the net force on the block becomes 0 and the acceleration becomes 0. Do we understand this?
Yes, sir.
Because y-axis forces are already equal. If the x-axis forces also become equal, it cannot move. Acceleration is 0. Do we understand this? Yes or no? It has gone above our head saying bye bye. I'm going. Don't worry about me. Do we understand this? Let us look at the blue case. Blue case. If F is greater than mg sine theta. Now can you tell me what will happen? F, blue case, is greater than mg sine theta. Then what will happen? If F is greater than mg sine theta, then what will happen? Yes. If F is greater than mg sine theta, then what will happen? Then this block will move upwards because upward force is more than the downward force. Upward force is more than the downward force. So this block will move upwards. What will be the equation of this block? It is moving upwards. Upward force is F minus downward force is mg sine theta. So upwards minus downwards would be equal to m into a. Do we understand this? This would be your blue case. Do we understand this blue case? Do you understand this blue case? Yes or no? Everyone? I'll give you 1 minute to note it down. Have you noted it down, everyone? Let us look at the pink case. Pink case. And the pink case is case number C. mg sine theta. This force is greater than F. Then what will happen? Then what will happen? Downward force is more. Upward force is less. How will it move? It will move in the downward direction. Then how will I write the equation? Downward force is more. So downward force minus upward force is equal to m multiplied by a. This would be the pink equation. If mg sine theta is greater than f. I'll give you 2 minutes to note it down. Have you noted this down?
Yes, sir.
So here is a question for you. A block of mass 5 kg is kept on a smooth inclined plane. There is no friction. Let's not worry about friction. We'll worry about friction when friction comes. A block of mass 5 kg is kept on an inclined plane. How much force should I apply here? F. What should be the value of this F? So that the block remains at rest. For what value of F block remains at rest? You can take the value of G as 10 meter per second square if you want to take it. For what value of F the block remains at rest? I'll give you 2 minutes to solve this. Everyone has understood the question, bacha? Everyone has understood the question, bacha? Okay, I'll wait. I want you to solve it and get confidence. Anyone with an answer? Shall I do it? Do you want me to do it, bacha? Hmm? You just have to do what you should have done in the first case. Remember, whenever I solve a problem, I draw a free body diagram. We've drawn the free body diagram so many times. Gives you 1 more minute to do it. Else I'll do it. Do I want you to do it with your own hands? But if you can't do it, I will have to do it with mine. Yes, beta. I'm having some answer. Yes. No one? Okay. Don't worry, then I'll do it. How are you supposed to do this? For what value of F block remains at rest? I draw the free body diagram. The weight of this is 50 newtons. I will, and the normal reaction would be R. I will need to resolve this force, so I'll resolve it. This is 50 sine 30. How much is sine 30? We don't know the value of sine 30. You must remember, no one is going to tell you this.
1/2.
Sine 30 is 1/2. So this is mg into sine 30. Mg is 30. 30 multiplied, oh sorry, mg is 50, not 30. Why I'm writing 30? 50 multiplied by half. So this actually becomes 25 newtons. Yes or no? Yes or no? And this becomes mg cos 50. 50 into root 3/2. Now it is not going to move along the vertical. So I can get the value of R as 50 root 3. No one has asked me this, but still I will write. The value of R is 25 root 3. Yes or no? That is the value of R. Now what they've asked is for what value of F the block remains at rest. When will the block remain at rest, bacha? When both the forces equate. So what will be the value of F? What will be the value of F? F will be equal to 25 newtons. If the value of F is 25 newtons, the upward force and the downward force are equal and nothing happens. The block remains at rest. Do we understand this? Do we understand this? Anyone got this answer? Okay. If you get this answer, then I will give you, this was question number A. Then I will give you question number B. If the value of F is given as 20 newtons, find the acceleration. If the value of F, remember in the first case, the value of F was not given, but now I made one more question. The value of F is not 25, it is 20 newtons. It is given to you. Can you now tell me what is the acceleration of the block? And I'll give you 2 minutes to solve this. Please do it. I will be very happy if you can do this.
Four meter per second square.
4 meter per second square is not correct, but well tried. Think again, you have just done a small mistake. Small mistake only. A small mistake. Anyone with a different answer? I'll give you time, don't worry. I want you to do it with your own hands. Because once you do the first question with your own hands, well, then you know that you have understood the concept of this question. So I'll give you time, don't worry. Once more, try. Something is missing. You missed some part. I've understood. How did you get 4? The answer is not 4. But I know that you can get this because you are on the right track. I'll give you 1 more minute. One more minute to get it correct. Yes, now I think you have got the answer. Yes, anyone? No one? Still?
Five, sir.
From 4, answer has come to 5. No. Okay, let me tell you the answer. Answer is 1. 1 meter per second square is the answer. Now can you get me the answer? It is 1. The answer is 1. Can you now get it?
F.
Anyone got it?
ఉజ్వల చెప్పు నువ్వే
I think now I should do it because everyone seems to have gotten confused. So how do you get it now? So I draw the same diagram and I write the same equation. My R is still equal to 25 root 3, yes or no? Nothing has changed in this R. The only thing that has changed in this question is instead of, and I will color it, instead of your F being given as F is now given as 20 newtons, yes or no? Now, when I look at the diagram, the downward force, and let me take this out. The previous question is gone. Now, when I look at this question, the downward force, blue force I see is 25. 25 force is downwards and 20 force is upwards. Which is more, downward or upward? Where will it move? Will it move downward or will it move upward? Where will it move? Downward or upward?
Downwards, sir.
It will move downward. I just need to find out this acceleration. How will I find out this acceleration? It is going to move downward, my dear friend. I take this blue thing. How will I write this blue equation? Dung, 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 dung. Downward force is 25 minus upward is also a force. Upward force is 20. That will be equal to 5a. Your acceleration will come as 1 meter per second square. Do we understand this? And this will be in the downward direction. Do we understand this? Do we understand this, everyone? Yes or no? Yes or no? I'll give you 1 minute to think about it and note down. Then I'll give you one more question. And if you can do that, that means we have understood this concept of finding out the acceleration of bodies. 1 minute. Let me know once you are done because I'll give you one more question in the same question. So with one question, we'll solve everything. Have you noted it down? Question number C comes now. If F is now 40 newtons, find A. In first case, you had to find out the value of A when the block was at rest. In second case, force was given as 20 newtons. We have found out that the block moved downwards with an acceleration A, 1 meter per second square. Now, I've changed the force to 40 newtons and now I'm asking you the same question. What is the acceleration, my dear friends? And your time starts now. And I sincerely hope that you are able to solve this problem. It will give you a lot of confidence more than anything. And that is what we need in today's lives, confidence that we can solve the question by our own selves. And these are the questions that are going to come. You might find the same question in your examination hall. Don't be surprised.
3 meter per second, sir.
See, I got the answer so quickly. Yes, that is correct. Let us give chance to everyone to pull this off. For everyone to understand and get this answer. It is correct. 3 meter per second upwards or downwards? Eh?
But
3 meter per second upwards. That is correct. 3 meter per second square, not second. Upwards. That is correct. Everyone got this?
Yes, sir.
Okay, everyone got it so quickly. I was not expecting it, but still I'll give 1 more minute to boys. Boys are in dark. I don't see them, and their future is also not looking very bright because in the darkness I can't see. Though Batman is my favorite comic character, he is the Dark Knight, but it's good that we stay in the light. We only become Batman at night, not in the day. Batman doesn't hunt in the day. He hunts at night. That is why he is a Batman. So let's hunt at in the morning. And how do we do this? How do we do this? Let me take this blue thing out. Let me rub this blue thing out. Dodong, dodong, dodong. And let me make this new question. So now, again, the same question remains here. This is still 25. This value of R still does not change. It is 25 root 3. Now, the force that I've applied is this, gentleman.
40.
This is 40 Newton now. Now I make it the pink case. Pink is my favorite colors. Pink, pink. Now I see 40 Newtons. Hey, where am I gone? I have disappeared. Dark Knight. 40 Newton is upwards here, and 25 Newton is downwards. So it cannot move downwards, my dear friend. It has to move upwards. So I make that arrow, and then I take the ding 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 here. It has to move upwards now because upward force is more. How much is the upward force? 40 minus how much is the downward force? It is 25. That must be equal to mass into acceleration, 5 into a. So my acceleration will be 3 meter per second square. In this case, it is upwards, which I am writing like this. I should not have written it like this. Probably this arrow would have given you more confidence that it is moving like this. Here I should not have written it like this. Oh, wrong colors. I should have written it probably like this so that you understand that this is moving downwards. Do you understand this, everyone? How this question is solved? Yes or no?
Yes, sir.
So this is a question of a block kept on an inclined plane. And now we will, I will give you a short note. You do not expect this question in the examination hall, but if it ever comes, you just remember this short note. If you have a block kept on a wedge like this, now sometimes what they ask you is, what if I give an acceleration to this wedge? If I give an acceleration to this wedge, what should be the acceleration for the block to remain at rest with respect to the wedge? So what should be the value of this A for block to remain at rest? For block to remain at rest with respect to the wedge. They sometimes ask this. You don't have to solve this. You just have to remember this. For this block to remain at rest with respect to the wedge, the value of this acceleration A must be equal to G tan theta. Just remember this as an important note. For block to remain at rest, it must be pushed in this direction, and the acceleration must be G tan theta. The second thing they can ask you is the reverse of this. I call it the reverse. It is actually not the reverse. Something like this. So the reverse of this is like this. Again, the same sort of circumstance. Again, a block is placed on a wedge. The angle is theta. Now they ask you, what should be the acceleration of the block for block to fall freely? What should be the acceleration of the block to fall freely? Remember, the direction of accelerations In this case, the direction of acceleration is like this. So if I accelerate like this, the block is going to fall. If I accelerate like this, the block will remain at rest. Do we understand this? Common sense? In this case, beta, the answer is G cot theta. So remember tan and cot. Just remember this as important points. You might not get this question. You definitely don't need to solve it. You just need to remember it. Do you understand this? This brings us to the end of this class. We have taken some steps in solving questions in Newton laws. Some more steps are left, and I think we should be able to cover those steps. Oops, where is this? We will be able to cover those steps probably by the next class. Let me see how much is done. I think by the next class we should. Oh, no, next class will take time. There are a lot many problems left which are likely to come. We also have problems of mass of a string. So, koi baat nahi, we will do this in 2 classes, today, tomorrow, and probably on Monday. So, I'll see you tomorrow and we'll try to wind this up. Please try questions at home. I've already sent you the sheet. Did you get the sheet? I thought that something was getting distributed.
Yes,
Probably
sir.
that's the sheet. It has a lot of questions. If you can do those many questions, I can assure you on a stamp paper that you will get questions from the same sheet in your NEET exam. Please do them. Okay. Take care and have a nice day. God bless you all. Bye bye.
Bye, sir.
Bye.